Alright, this video is about optics, the basic study of light. A couple things about this particular topic is we're going to split it into two parts, geometric and physical. Geometric optics, we're going to concentrate on treating light as a stream of particles. It's also sometimes referred to as the ray model, so we draw light in nice straight lines. And then we'll do another unit on physical optics where we treat light as a wave. Okay? So one of the very first things that we'll talk about with light here is reflection. So we talk about reflection in a plane mirror, like the mirror in your bathroom or something like that. Those are all plane mirrors. They're flat. They lie all within one plane. If we take a look at a ray of light that might strike the mirror, it's called the incident ray. Okay? As it strikes the mirror, it gets reflected, and we have what's called the reflected ray. Now, the angle at which the incident ray measured to normal and the angle at which the reflected ray measured to normal, those two angles are the same. Okay, so we have what's called the law of reflection, which says the angle of reflection equals the angle of incidence. Now, one thing to make note of is that both of those angles are measured from normal. Now, that is a nice shiny mirror, but light will reflect off just about anything. But if it's not a shiny surface, the reflection is very poor. We call that diffuse reflection. So when the reflection of light is reflected in all sorts of different directions because it's not a nice, smooth, shiny surface. For example, you can see the light on a piece of paper. Like if I turn this light on, you might even be able to tell. No, you can't really tell. But if you took a flashlight and you actually shined it on a piece of paper, you could see an image of the flashlight, but it would be really fuzzy and hard to really make any clear image from it. Okay. All right, so image. When we talk about image, we're really referring to what you see. So if we have a mirror and you're standing in front of the mirror, so here's the mirror and here's you. Okay. When you stand in front of a plane mirror, the distance between you and the mirror appears to be the same as the distance between the mirror and your image. Also, however tall or the height of you in that mirror is also the apparent height of that image. So we get a relationship that says the distance of the image is equal to the distance of the object, or the height of the image is equal to the height of the object. Okay, this works in plane mirrors. Okay, so then we have to talk about different types of images. We have two different types of images: a virtual image or a real image. If you look at the definition for a virtual image, it says an image that would not appear on paper or film at the image position. And I have on there an example of a mirror in the middle of a room. You can think of a virtual image as an image where the actual light rays coming from the source will never actually cross. So if you've put a mirror in the middle of the room, you see yourself in the mirror, but if you were to go on the opposite side of the mirror, if somebody was on the opposite side of the mirror and they put a screen there, the rays from you would never have a chance to make it there because the mirror blocks it. So that is the type of image known as a virtual image. Whereas a real image is where light can actually get to that particular location. So oftentimes when you use like a lens or curved mirrors, it will reflect or refract the light to a point where all those lines will, or all those rays will cross, and you could actually get them to show up on a mirror or on a screen or something like that. So sometimes we refer to real images as images where the rays of light actually cross. Okay? Now, plane mirrors only produce virtual images. However, curved mirrors and lenses can produce both real and virtual, and we'll start getting into those in a little bit.